Okay. Welcome everyone. Hello, hello. Welcome back to week 2, lecture 2, or lecture 4, I suppose. Hello, hello, hello. Audio's looking good. Yep. Hey everyone. All right. Let's get straight into it because the 2 hours goes so fast. Good to see most of you back after yesterday. So yeah, as a few of you have identified today, we're talking about increase the audio. I can try input. Oh yeah, I can definitely try. How's that? Is that better? Is that better? Thank you. All right. Okay, we can finish off the Kahoot yesterday. Yeah, cool. Okay, welcome back to the Wednesday lecture where we're all talking about loops and repetition, while loops, all that good stuff. Really exciting topic, really fun topic. And we're just going to get straight into it, basically. So yesterday, what did we cover? Just to go over it. I don't think we spoke about conditionals again. Very briefly at the beginning, we covered it again. if statements we sort of didn't cover, but we introduced structs and enums. I saw some comments, one comment on the forum and someone in the chat mentioning that, is this better? Mentioning that the struct code on the course website was a bit complicated. If you remember from the lecture yesterday, right at the end, I did some I extended the struct code that we had, if you recall. But obviously what that meant was that was the final version that was left up. So after today's lecture, I'll put it back to the way it was and I'll leave the current one as a separate file. Does that make sense? Because I think if people have just looked at it for the first time after the lecture, maybe they got a bit confused because the example was a bit complicated. But, so I'm happy to do that. So yeah, basically we spoke about structs and enums. Do we have any questions about the content that we introduced yesterday? I know it was a lot of content in a short amount of time. That's just the nature of these lectures. Next week, when you go to your tute labs, you'll have a chance to actually get your hands dirty with the concepts, and that's when it'll start to set in. So if you're feeling a bit, sort of like you're not understanding the content, really that's okay. You've only had one quick 2-hour lecture on them. You're not expected to absolutely, understand it all straight away. Cool. Okay. So any questions about yesterday's content? Structs, enums, custom data types? Kovsky, that's correct. Okay, well, I'm going to just get started, I think. Okay, loops. We're talking about loops, say. One of the most important control or structures that we have in procedural programming. So sometimes I call this concept repetition, but basically the idea is that we can repeat ourselves in code without actually repeating the code, typing it all out that we want to execute. As always, you can scan this QR code or just visit this link to get, oops, there's no good spot to put the webcam, is there? You can visit this QR code or URL, and someone will put it in the chat as well, to access the live code that we're writing in today's lecture. I'll give everyone a few seconds to scan that up. Joshua, you could scan in to mouseposition.x. It's just another variable, basically. So you can do whatever you want. You could assign it a value, you could scan f in a value, whatever. Okay, thank you, Patrick. We got the URL in the chat. That's probably enough time. Yeah, Joe, that won't compile. Get wrecked. So what is looping? Why do we need it? How does it help us? Basically, sometimes when we write programs and we solve problems, the solution is to do something more than once. So repeating ourselves, basically, until a certain condition happens or something like that. So can we think of some examples of real life where we have sort of these problems or solutions that involve repetition? And in many ways, most algorithms or most algorithmic things that we do involve some degree of repetition. It's very uncommon that in one swoop or one pass, we can solve a particular problem. So for example, if you're going to go through all the songs in your playlist, you're looping through each song, right? Jacob says, sensors constantly checking values. That's a good one. You can't just check all the values once. You've got to do that over and over again. Alarm sounds. That's a good one. Instead of you're not playing 50,000 sounds. You might play the one sound repeatedly until it's over. Sponge cake folding. That's a great example. Like making croissants, I don't know, that's a weird example, but you have to repeat the action many, many times so that you get the layers. Typing in the wrong password, that's a fun one. And light cursor, that's also very funny. If you need to print out asterisks a lot of times, a callback to our assignment. Yeah, so there's many examples both in real life and in abstract problem solving and algorithmic problem solving that the solution is to repeat ourselves. But programmers, and this is the key, don't like repeating ourselves. We like to do things once and make the computer repeat itself. And that's what loops or while loops help us do. And so this slide really sums it up quite nicely. Repetitive tasks shouldn't require repetitive coding. Just because we want to print something 50 times, I don't want to type 50 printf statements. That's not a good use of my time. I can make the computer repeat itself. But if we think about it, and we think about our C programs, we know that they normally execute in order, line by line, starting with that special main function. So if we have 4 printf statements in main, right, we jump to main, we run the first printf statement, we run the second printf statement, we run the third, and you get the idea. It just runs in sequence. We can control that sequence, remember, with if statements. So we can say, if some condition is true, do something. If some other condition is true, do something else. So only one of the branches will execute, for example. We can do that. But again, we have no way to repeat ourselves. Our programs execute and they just run through to the end of the program, if we all agree. So how could we solve, and let's actually jump to VLab here. Oh, nothing's open. That's okay. Oh, not Z. What am I doing? Public HTML. 151 lecture code. I'll go to week 2. Let's go gedit loops.c ampersand. There we go. Okay, cool. We've just got some program here. Let me bring that over here. How have you all been finding reading the code on the lecture? Is it big enough, the text? So quickly, what I was just talking about, if we've got this main function and we've got a printf, we want to say hey. If I want to print out this hey 4, 5, 10, 100, 1,000 times, I do not want to sit or stand here, in this case, going printf, hey, that's not a good use of my time. If only we had some way where we could tell the computer that we want to repeat this task. And in fact, that's exactly what we can do. So we don't want to copy and paste the code or repeat the code. It's not flexible, right? If I've got 50 lines, how do I know that I've got 50 printf statements? I'd have to count them. And it's not a good example. So we have in our languages, in the C language, these mechanisms that allow us to tell the computer, the machine, hey, I want you to actually repeat something a certain amount of times. And the most basic way we can do this is with what we call the while loop. The syntax of it is actually quite simple. It uses a special keyword called while. This is an example of one of those reserved keywords that belongs to the C programming language. So you can't make a variable called while, for example. This has to be called while. Then what we have is the condition or the expression that evaluates to a condition. So just like with our if statements, we said if, and then we had some expression that evaluates to true or false. So if something's true, do something else, do something else. In this case, we have the exact same thing. We need to have a Boolean expression or some expression that evaluates to a true or a false in the brackets of the while statement. And then we have a pair of curly braces to indicate the block of code that is going to execute in the while loop. And so with already just this very simple building block, we can actually say, I want to print, the string hey, X amount of times just by using this while structure. So if we think back to that slide, how do we write a while loop in our C programs? Pretty simply, we just say while. That's the key word there, the special keyword. The C language knows if it sees the word while, we're probably writing a loop here. We're definitely writing a loop here as long as we get the syntax right. Then I put a pair of braces, okay? And in this case, it's some condition that needs to be true. Or that needs to evaluate, to true or false. Only if the expression evaluates to true, right? Only if this is true, will the loop continue to loop. Will the loop continue? I guess that's right. And then we need our pair of braces here. So instead of having this printf hey, going on forever, we can delete this line, we can cut this line, and we can paste it in the body of our while loop. So if we think about this, while, we have our while loop, some condition, in this case it's always just true, I want to execute this printf statement. Now, I think actually, we can actually run this loop just like this. So I've got a question to everyone. We won't do a poll, but I have a question. How many times is this going to loop? And some of you have already sort of thought about what this might mean. How many times is this going to loop? So Daniel says 0. I'm curious to see why you think that. People say infinite, infinitely, infinitely, forever. That is the correct answer. Why is that the correct answer? Well, this expression, true, is never, ever going to be anything but true. I've literally said, always loop. While true is true, continue to loop, and true will always be true. But there's nothing stopping us compiling and executing this code. Yeah, only one way to find out. I agree. So how do we compile? Remember, we save the file, we jump to our terminal, DCC, this file is called loops, into our loops program. We hit enter. Okay, there is no true in C actually, is there? I use 1. Or I might have to include std bool, actually. So I jumped ahead of myself. So if we remember, whoops. True is 1, false is 0. So 1 is equivalent to true. I think in C++ you get true as a keyword, so that's probably why I got confused. But anyway, so let's try compile that again, and that works just fine. And we can just run our loops program because that's what I called it. And you can see that my program is just infinitely printing out hey followed by an exclamation mark. Not even a new line because I didn't put that new line there. But you can see this is already, now I'm going to quit my program. Oh, that's cool that DCC does this. I had to force quit my program. So I actually had to tell my operating system to drag my program around the back of the barn and put out of its misery because without doing anything, I never was able to make my program stop executing this loop. And yeah, the way I force quit or force killed this program is by doing Control-C in the terminal. But this is pretty interesting already. We've written a while loop. I mean, that's already quite exciting. We've told the computer that, hey, while this expression evaluates to true or 1, just continue to print hey. Now, as you may be imagining, we don't want to print things or run these while loops forever, right? That's not what we want to do. So we need some ways to sort of limit our loops. Okay, well, this is the example I've just sort of spoken about. It's very easy to make our programs loop forever. So I could say while 1 is less than 2, that's always going to be true. It's going to loop forever. Or I can just loop for true. That's what we just did. But we can control our loops to only loop a certain amount of times that we want it to loop. And the way we do that is with a counting loop. Now, when I say we use a counting loop, it's not a different type of loop. It's not a special type of loop. It's just a while loop. All of these loops we're going to be talking about are just different ways to utilize the while loop. If we have a look at the slide here, we can use a variable to control how many times the loop runs. And we call this a variable a counter. We use an integer because we're counting whole numbers. That makes total sense. And we always need some sort of termination condition. So the condition at which the loop runs. 99% of the time when we build our loops, we always want them to end at some condition. And the other key is that we need to update the value of this variable inside the loop. And usually what that means is to increment it. So let's jump back to our editor. And again, you can follow along, typing this program out if you'd so like. So we don't want to just loop forever. We don't want to do that. Let's say we want to loop it 5 times. So what do I need to do? I need to somehow have some counting variable that loops 5 times. So if I need a variable, I need to declare a variable. I need an integer because I'm counting whole numbers, so I can just make an integer. Int, we can call it count, and I can assign it to 0 straight away. So make this integer, start it at 0, assign it the value of 0, and we're on our way to having this while loop. So at what point, at what condition do we want our while loop to evaluate to false and stop looping? Well, we want it, let's say we want to count to 5. We want to end it when the count is equal to, well, we'll do 4 because I'm starting it at 0, 0, 1, 2, 3, 4. So that is 5 times. You got to remember that. If you start your variable at 0, you got to subtract 1. If you want it to count 5 times, you have to do 4. So this will loop 5 times. Now, are we done yet? If I compile this and I run, is this going to loop 4 times, or is it going to, what's it going to do? People say no, some people say 4 times, nothing. Print once, print 0. Won't loop at all, won't loop at all. So a lot of people saying no loop, interesting. Oh yeah. Not print, that's right. Because count will start at 0, 0 is not equal to 4, therefore the loop will never run. So what we need to say is while our count is less than or equal to 4. So if we think about it this way, the count will start at 0. Is count less than or equal to 4? So is 0 less than or equal to 4? That's true. Okay, it is less than or equal to 4. It'll print it. I'll get to the end of the loop. We'll go back to this. We'll go back to the expression. But count will still be 0, right? So we're kind of stuck here because how many times is this going to run? Yeah, infinitely. And why is it going to loop infinitely? Because count never gets incremented. So this is the final part of our while loop that we're missing, is to take count and make it equal to, right, single assignment, the value of count, which is in the first case 0, plus 1. And we do that after whatever we're doing in the body. We could actually do it before as well. All right, so now let's think through this. We have this variable called count. We assign it 0. So it's going to start at 0. Is 0 less than or equal to 4? That's true. We printf the hey. We make count equal to count plus 1. So now count is going to be 1. And then we'll come back here and say, is 1 less than or equal to 4? Right? All right. That's still true, but we're making progress. We're getting closer and closer to the point where count will go to 1, 2, 3, 4, 5, and then the program then the loop will stop executing and we'll reach into the program. So why don't we save this, clear this terminal, compile this, whoops, that compiled okay, I think, and then we'll execute this program. And then what do we see here? Our beautiful 1, 2, 3, 4, 5 hey that gets printed out. To make it a bit nicer, we can print out our \n right there, clear this, compile this, and run this. And this is our very basic, very introductory, a very introductory counting loop. So Sophie says, what exactly does the +1 do? This count variable, this integer, starts at 0. And we want this loop to execute only 5 times. So I need to add 1 to the count each time the loop runs, so that after the 5th time, this evaluation, when count gets to 5, this will evaluate to false, and the body of the loop will stop executing, and then we'll return 0. Now, a few of you I can see are going nuts in the chat, asking about the post-increment operator, the ++. So you're asking, could we do, or maybe some of you are telling me, hey, Jake, you fool, why don't you just do count ++? I'm just keeping it simple. This is another example of syntactical sugar, in that it's a shorthand for this, but there's nothing wrong with typing out, the full expression. So count ++, basically adding 1 to a number is such a common operation that built into the language is sort of a shorthand for taking the value and incrementing it by 1. You can also do += to 1, but again, that's just shorthand for taking the value on the right, evaluating this value, adding 1 to it, and assigning that new value to the value on the left. So you could do count ++, you could also do count += to 1. Okay. Are these comments, whoops, that should be equal. Yeah, semicolon. Are these comments helpful when you're reviewing the code, or would it be cleaner if they were taken out? So, just to reiterate the fact of why we need to have this counting variable. Remember I said in week 1, and I'm going to continue to say this a lot through 1511, our computers are unintelligent. If I want the program to do something 5 times, I need to keep track of how many times the program has done something. This is just like humans. If I tell you to write your name 5 times, yeah, 5 is low enough that you'll just write your name 5 times. But if I say 100 times or 50 times, somewhere you'll need to count how many times you need to do something. And just like we need to keep count, and we need to count out how many times we do something, so do we need to help our programs keep track or count how many times we want them to do something. And if we're counting, we use an integer because it's a whole number, and that's just how we count. 1, 2, 3, 4, 5. They're integers. Okay? All right. So this example here is doing the exact thing, although the lecture code says it's time for some Messina ice cream, which is not too bad. Okay. Now, what's this code saying? This is the same, right? We initialize our count just before the while loop. Okay, some other people actually asked why. So if I want to loop 5 times, go back here. If I want to loop 5 times, why did I do less than or equal to 4? Why didn't I do count is less than 5. They're both equivalent. Right, these will both loop 5 times. They're just equivalent. Yep. There's nothing really special to say about it. Oops. Okay. Now, what we do in the body of our loops is just execute more code. So in this example, right, we have our counter initialized. We establish our condition. So what gets checked every time the loop runs to determine whether or not the loop will actually run. Yeah, that's meant to say scanf, good catch. We print, we can do something like ask the user, how many scoops of ice cream have you had? We can read that number in, right, into our variable over here. We can add it to some sum and print out the total. Do we want to implement this program for practice, or do we want to continue on into some new topics? This isn't doing anything extra with the loops. It's going to loop 5 times, but it's going to do something every time the loop runs. Yep, okay, we can implement it. A couple of yeses. I mean, it's pretty silly of me to ask a question like that because we get a 50-50 answer and then I can't win. So I don't know why I do something like that. Don't worry about it's really hard to get code formatting in Canva in the slides. So it's not perfect. Like don't worry about the exact code quality. All right, why don't we implement it? But I will put the code to the side and I'll implement it more quickly just so you can see it, but I'm not going to go really, really slow, right? So we'll go through the practice of using it, but you can watch back the video or just, rewatch content. I'm not expecting you to type along with me, if that makes sense. All right, so what do we want to do here? We want our count variable. We want our int scoops equals 0, int sum equals 0. So we've got these 2 integer variables that we're going to use. While count is less than or equal to 4, or we could have said while count is less than 5, that's fine. It's going to print loop 5 times. We're going to print how many scoops this time. Okay. Then we're going to scanf. We're going to scanf an integer, so %d, into the variable scoops. And because we're reading in, we need to sort of tell the compiler that I want to edit or assign a value into this scoops variable. So we put the ampersand in front of the variable. And remember, we're going to talk more about exactly what that means in future topics. So we read this value into scoops, and then basically we want to add on to sum how many scoops we've had over our 5 iterations. So sum is going to be equal to the sum plus the value in scoops. So if I have 1 scoop on the first loop, 2 scoops on the first loop, I've got a total of 3 in the variable sums. And then we always have to add 1 to the count. Always have to add 1 to the count. And then what we'll do actually, instead of printing the sum in the loop, we'll print the sum. Yep, this is fine. Printf %d. You had, why is the random spaces going? You had a total of %d scoops \n, scoops. All right. Hopefully I've not made any mistakes, but that's completely possible. We compile this program. There was an error and I forgot a semicolon. That's definitely my theme. That compiled okay. Let's run it. How many scoops this time? Let's say I had 1 scoop, then 3 scoops, then 5 scoops, then 0 scoops, and then another 1 scoop. I had a total of 1 scoops. Okay, what's going on here? Ah, okay, what did I do wrong here? Someone tell me. Yeah, I printed out scoops which just had the final value that was in it at the time that I printed it out. So I actually wanted to print out the sum there. Okay, save, compile, run. Let's keep it simple. 1, 1, 1, 1, 1, and we should see that I had a total of 5 scoops. Awesome. So then we did something a little bit more complex in our while loop program. But the key structures are always the same. The condition, the things we want to do, the increment, and then contained in the block of the while loop. All right. I will leave the loop.c file at that point. So what we'll do now is we'll go back to the slides and determine what we want to do. Okay. So that is counting loops. Okay, one more thing I want to add to counting loops is that let's get rid of, oops. I'll undo this. Actually, I'll undo this, but no, we always need that. The value of, the power behind programming is that, look, anyone can do something 4 times, 5 times, but I can make a program, 400 times. I add 2 zeros to this one line, and then all of a sudden I get a program that, we can ignore that does something 400 times, right? At a scale that humans aren't really good at. And this is where the power of programming and computing come into effect, where the computer can do things at a speed so much faster than us that with, and again, 400, that's nothing. 4,000, 40,000, whatever it is. Okay, but let's bring all this back. Okay. All right. Another way we can use while loops is with Sentinel values. So what is a Sentinel value? What is a Sentinel loop? So when we use a loop counter, we assume that we know how many times we need to repeat something. So if we go back to our code here, I know that I wanted to ask the user exactly 5 times for how many scoops of ice cream that they've had. I know the number. I know we want to loop 5 times. We want to print out, hey, 10 times, right? We know in advance the exact number. Whoops. But sometimes we don't know how many times we need to do something in a loop. We don't know when we'll be finished. We know what finished looks like, but we don't know how many times it'll take to get there. So the way we can solve this problem is by using a Sentinel value or a flag value, which is what I've heard them called more often. Filling up some water. So an example of this, if I'm reading in numbers from the terminal, from the user, and I want to keep reading numbers until I get an odd value, right? I don't know what the user is going to type in. I don't know how many times it's going to take. It could take 1 time. It could take 50 times. It could take 2,000 times. But I want to keep going at it, keep repeating our code, until the user enters in an odd value. Once we have an odd value, we know we can stop. So this is a pretty simple, contrived maybe, but appropriate problem. So we can use the Sentinel loop to decide when we need to exit. This is a pretty repetitive slide, actually. Do we have some example? Okay. So this is a similar example as the previous one. We're still using this scoops sum. You notice in this example, we don't have count. We have this thing called end loop. Then the code says, while end loop is equal to false, right? Because 0 is false, we will just continue to loop over and over. Why don't we do as the example, so I'm going to just clear this, gedit loops _2 .c ampersand. So I'm going to make a new file here so that we can, I'm going to just try and do this more often so that you can come and have a look at the different versions of as we progressed through the program. But actually, I might just copy this and start from it. Okay. So we're going to convert this to use a Sentinel or flag-based loop. So we're not going to do a count this time because we're not running the loop n number of times. We're running the loop until something happens. It's another way that we can use loops. All right. So I'm going to actually call this should loop. Now, we can assign it to 0. Remember, 0 means false, 1 means true, but it doesn't even really matter. It just matters how we want to use and use that variable in our condition when we run the loop. So we're not going to loop 5 times. We're going to loop until should loop is, 1, let's say. This might be slightly confusing. Do I stick with the lecture code or do I do what I think makes more sense? Let's stick with the lecture code, potentially. And get rid of that, because that might be confusing, I think. Do what my gut tells you. Okay, do what I think. All right, thank you all so much. That's really cute. Okay, well, the variable is called should loop, and we remember that in Boolean logic in programming, 0 is false, 1 is true. Therefore, we want to loop while should loop is true, and true is 1. Therefore, let's start it off by assigning should loop 1. Does that make sense? We want to loop while should loop is true, and true is 1. And actually, it lets us do something that it wouldn't let us do the other way around. Okay, and we actually want to loop until should loop is 0 in this case. Okay, so we don't want to loop while we don't have count anymore. We're going to delete that. We want to loop while should loop is equal to what? Yeah, Daniel and Justin, you're both correct. In C, there is no Boolean data type. It just is an integer that is 0 or 1. They actually added bools to C via stdbool.h. We're not using it in this course, but they did add it to C. And that's why I think it's better to start should loop as 1. Yeah, we want to loop while should loop is 1, because 1 is true. If a bit is set to the value of 1, that is truthy or true. So while should loop is true, we can run this loop. All right. AR11 says C is kind of primitive, not going to lie. You're 100% right, and that's 100% the point. The point of C is that it's mapped very closely to assembly language. So it can compile very closely to how we solve the problems. Anyway, let's not get too philosophical. Okay, so we want to loop while should loop is 1. Yeah, Daniel and Anuba are right. You could make an enum to do this, and you could have true or false, but they're both integers, right? But you could 100% do that. So that's a really good catch. That's a really good catch. Pahan, you're jumping ahead of what I wanted to do, but I'll do that after. But good catch. Okay. All right. I like the idea of just reading in until we get an odd number. Oh no. Okay. Maybe I see why. Okay, I've got an idea. All right. Let's just say enter in a integer. We're going to scan if an integer. Now we don't have scoops. We just had user integer. Let's just have that. Get rid of sum. Copy this. Oops. So I'm asking the user to print, enter in an integer. We scan that in. We're not going to do that. And we don't have a count anymore. That's fine. Ooh, my eyes got itchy. All right. So we're scanning in a value to use integer. Now, this again will just loop. Let's get rid of this. This again will just loop forever because I never change the value of should loop. So what I can say is if user integer. Now I can make up any condition I want here. So what's some condition that's pretty easy to check? So I could say if the user enters in a number greater than 10, greater than 5, something like that. That's reasonable? I think we can do that. If the user enters a number greater than 10, that means we want to stop. That's probably not greater than 10. So what do we have to do to stop the loop? Exactly right. Exactly right. Should loop is equal to 0. Because when I set should loop to 0, 0 is not 1, therefore the loop will end. And I'm going to show you a technique to better understand these programs in just a moment. But let's first of all save this, compile it. This is loops_2 now. Whoops. Okay, that's pretty cool that it's done this. Oh, I've made an error here. And actually, my compiler is giving me the note just as you are all giving me the note. I'm assigning 0 to should loop here, so it's a single equals sign. It actually picked this up. That's pretty cool. All right, let's compile that again. We're still going to get, we don't even get one of them. Yeah, cool. That makes sense. All right. Thank you again, compiler, for helping me. Okay, we've compiled to loops. I think we compiled to loops_2, so we can just loop that. It's going to ask me, enter in an integer. All right, let's enter in some numbers less than 10 that won't trigger the sentinel or the flag, right? So if I enter the number 4, it's going to ask me again. It's going to loop. If I enter the number 2, okay, 0, -2. It's just going to keep. I know you like the sound of my keyboard, so I can just keep doing that. It's going to just keep looping while this number that I'm entering is less than 10. But what happens if I enter in a number greater than 10? The program ends. How cool is that? Because user integer is greater than 10, therefore should loop gets set to 0. It finishes the if statement, finishes the loop, jumps back to the loop, and it says, is 0 equal to 1? That is obviously incorrect or not true. Therefore, the while loop doesn't run and we return 0 and end the program. Whew. Anubav, yes, DCC is made by CSC, specifically Andrew Taylor, who's a senior lecturer here in the school. It's a really cool project if you're interested in compilers, maybe in a few terms. Once you've got some more courses under your belt. So Nikhil says, in C, is 10 greater than 10 a true statement? Let's think about it. Is 10 bigger than 10? No. So therefore that would be false. Abby says, does break also stop the loop? Yes, it will, but we're not talking about that just yet. Okay, I wanted to show you something. Look at this at first. We're going to prop, sort of. Let's do this. Let's not do this. Let's do this. Okay. So I got my iPad here that gets synced to my, well, I've got nowhere to rest it. Okay, move. All right. I want to talk about, why don't we do it like this? Is this working? I want to talk about how we can, now what's happening, right, is we're getting these more complicated programs with variables that are tracking state. And we need to, that's really annoying. We need to have a way, I can do it like this, I think, to, I'm going to show you a technique for keeping track of these programs and how they work. So you can do this alongside your programs, or if you're solving a particular program, you're reading a particular program that's getting the best of you. This technique I really find super useful. I promise you, right, it's a good introductory technique when you're learning programming, but years of software engineering experience in industry, I still brought out a pen and paper or a tablet or something like this and hand executed my code to help me get my head around what a particular program was doing. So we're going to do that really quickly up until the break, and we'll try and run a Kahoot for the break as well. So something a bit different. So I've got this program here, and let's just say I'm not getting my head around this program. What should I do? I could stare at it for hours and hours, or I could take a step back from the keyboard and try and understand what's going on. So what I'm going to show you is just a really simple technique to keep track of the variables in our program. So how many variables do I have in this program? Benjamin says 2. RB, Nickel, Windows. Yeah, 2. Exactly right. We have user, integer, and we have should loop. So when you do this technique, right, really simply just for every integer, for every variable you have, just draw a box that represents the variable that stores that value. Then we execute the program by hand. So I'm not going to compile it, I'm not going to run it, I'm going to run the program by hand. So let's go. We start our programs where? At main. We jump to the first line in main. What does this line do? It tells us, hey, we're assigning the value 0 to the variable user integer. I look at my variables list, there's user integer, I'm assigning it 0. So I put 0 in the box. Let's go to the second line, line 7. What's this line doing? It's putting a 1 in should loop. Okay, let's put a 1 in should loop. All right, simple. If we run the program line by line, it's simple. What complicates us with loops is that we try and execute the loops in our minds and it doesn't really work. So let's not bother. Let's just run it as the program runs it. All right, line 9 is a comment. So what? We do nothing with it. We get to line 10. We've got a while loop. Okay. So we need to think and we need to execute the while loop just like the computer executes the while loop. How does the computer execute the while loop? It comes along and it says, well, what's the condition? The condition is should loop 1? All right, we look at our box. We have should loop. Is 1 equal to 1? That's true. So we jump into the body of the loop and we execute the loop. We come here, enter an integer. All right, we need to say the number that the user enters in. So we could say that the user enters in the number 20. We could just draw that down, for example. Then we could say, is 20 greater than 10, right? Well, that is true. Oh, what am I doing? That gets assigned into user integer. So let's get rid of this. We can cross this out and put 20 here. All right, use the variables that we have. Is 20 greater than 10? So we say is user integer greater than 10. We come and have a look at user integer. That's 20. 20 is greater than 10. That's true. Therefore, should loop is now assigned the value of 0. We cross that out. We put 0. the if statement ends, this ends. What do? We go back to the while loop, and then we say, is should loop equal to 1? Well, what's should loop? Should loop is now 0. Therefore, 0 is not equal to 1, and it ends, and the program ends. So this is just a really simple technique. I really recommend, if you're getting stuck in your programs, to get a pen and paper out, or get a whiteboard or something like this out. And you'll see, once our programs get more complicated or whatever, we'll pull out the iPad and do this. Yeah, so right now there's nothing too revelatory about the process, except that once the programs get more complicated, I promise it will help you understand what's going on. Yeah, and Patrick's comment is 100% too. Another really good technique is to take a break. More than 10-15 minutes on a problem, it's a good time to get up, have a stretch, and shake it off. And with that, what excellent timing. It's now 3:57. So let's have the mid-lecture break. In fact, what am I doing? I think I minimized it. Why has it gone over here? Okay, yep. Let's have time to stretch. We've got a thing here. Okay, well, everyone wants the Kahoot, so let's just do the Kahoot. Oops. Oh, what's this doing? While I get the Kahoot up, you could... Oh, why has it logged me out? All right, I'm back in. Okay. What is this? Tammy, could maybe you send me the Kahoot again for some reason? Oh, here it is. I've got it, never mind. I just need to edit it a bit. I need to get rid of the old questions. Edit Kahoot, okay. Trying to remember where we stopped yesterday. Okay, I think this is good. Save this. Yeah, that's what I'm doing. I'm getting new questions. All right, play now. Start. Classic. All right, there's the pin. Everyone wanted the music. Oh, it's the wrong music? Oh, okay, yeah. It's very... I think that's better, right? It's very complicated because I can't hear it. I need like audio monitors. That's what I need. There's a way to do it. Anyway. I'm sure one of you is like way better at live stream production than I am. So I need someone to like give me a hand. Yeah, Kahoot vibes only. Let's see how many people are in the stream. Oh, 200, okay. Yeah, me playing off screen. Okay, we'll give it a go now. I feel like if you're in, you're in. Then we start to get onto the weird usernames. Overthrow Jake, I agree. All right, 3, 2, 1. Let's give it a go. Yep, cool. Good name. Okay, which of the following declares and initializes a variable? Do you want me to read out do you like my announcer voice? Is it nice? Oh no. Oh no. I see it, don't yell. I know, I'm sorry. It's the right one as well. Okay, that was practice. That's right. It's rigged. I know. I know. Oh, goodness. All right, that one was practice. That was warm up. If Jake Renzella gets on the board again, it's going to be chaos. It's going to be chaos. Okay. If I wanted to ask the user for input in my program, what function should I use? Printf, scan, input, or scanf. Come on, this is an easy one. There we go. 101 of you have correctly identified that in C, we use scanf. I mean, this question didn't specify that it should be C, so let's see. Printf is for printing, that's fine. Scan doesn't really do anything. Input, I think what language uses input? Surely there's a language that, is it just Python? Yeah, I think it is. Okay, there we go. I'm not even going to read that. But at least Jake Rundell is not first. Yeah. Okay. I just taught the Python course last time. I should know that. What is the correct format for scanning in an integer into a variable number, and assuming that number is already declared? Yeah, cool. I need to do like ASMR on stream. There we go. Very good. 106 of you. Scanf, %d for a decimal integer, open up the number variable as a pointer and put the value in with a semicolon. Very nice. Very good. You're doing very well. Yeah. Tabby. Again, Seski on top of the leaderboard. Hopefully that doesn't mean anything. I don't understand. Why do we use if statements? Oh, that is an ASMR term, is what you're saying. Anyway. This one's an easy one again. Yeah, very philosophical. To execute different blocks of code for different conditions, exactly. And maybe to make our lives difficult. There is actually, now I'm getting off track, but there is a style of programming I've seen recently somewhere which avoids if statements because now we're getting really off topic, but it is the lecture break, right? But when you have branching in your compiled code, the compiler optimization can't determine the output or the branch that gets taken. So therefore, it's hard to optimize anytime there's a conditional. And if you reduce if statements and you reduce your branches, then you can better optimize in the compile stage. So there's this like paradigm of programming that avoids them, but it's not something I'm very familiar with. But anyway, everyone's getting it. Is it always? It's always 109. It's neck and neck. We'll do one or two more. Determine the value of the following expression in C. This is a good one. 1/2 by 500. This is a very good one, actually. Oh, 16 15 people said 0. 51 said 250. Interesting. 41 said 250.0, which between yellow and green is definitely the right answer. But yeah, a division and a multiplication are the exact same level, right? So it will just be expressed in order, and one divide. Why is it 0, Tammy? I mean, is this... Okay, it's because 1 divide 2 for integers can't evaluate to... Yes, that's why. Can't evaluate to 0.5 because it's an integer, so it rounds down to 0. 0 by 500 is 0. There you go. It's a good question. It's an integer division problem, which I made in the first lecture. Jake Roselli got knocked out. This looks really bad because I even just asked if it would be 0, but Seskieski, whoever you are. It's not that it's rounding down, Joe. It's that it never reached 1, therefore it is 0. All right, one more question, because that was a good one. And you can type the code in your program to test it out. All right, another example. Okay, this is an even good one. Determine the value of the following expression in C. 1 divide 2.0, so similar to the previous one, by 500. So I am going to lock in my answer. I think it's green. I think it's 250.0, and that is correct. 60 of you got it that time, learning something from the previous attempt. 29 of you said 0. Why is this different from the previous one? It's a good point. It's because now 2.0 is a float. Therefore, the result of this operation will be a float. And because it's a double or a floating point, it can be 0.5. So 0.5 times 500 is 250.0 because it's a float or a double. So only the right-hand side has to be a double for it to evaluate to a floating point. All right, let's end the Kahoot there. How do I even end it? End now. So we'll do the podium. G came third. Oh, I mean, all of you got 6 out of 6. Very good. Jake's dad, but coming in on top. Seskieski. Yeah, I've got foot pedals under my desk playing Kahoot. Nicholas, you ask a good question. What's the difference between a float and a double? Well, we can always Google float versus double in C. Let's have a look. Geeks for Geeks, this website always comes up, but maybe let's open Stack Overflow. Float versus double precision. This is in C, I think. It's always good to confirm what language. Yep, in C. Floating points numbers in C use the IEEE 754 encoding. This type of encoding uses a sign, a significant, and an exponent. Significant, I never heard that word. Because of this encoding. Okay, here we go. Here's the interesting bit. A single precision or a float gives you 23 bits with an 8-bit exponent and a 1 sign bit, whereas a double gives you 52 bits. So, I mean, you can sort of just glean it by reading this. Double is double the amount of precision or values that you can store than a float. I think there's also single. No, there's no single in C. Is there no single in C? There might not be. There's some language that I know that uses single and double, but I don't remember what it is. If anyone remembers, or if anyone knows, that would be cool. Yeah, float is just the standard floating point, and then double is double that. Yeah, there's short double. There's a lot of different data types and a lot of different languages. No, it's not Python. What is this? Go away. Is it Pascal? Yeah, okay. I think it was. Yeah. Single, double, extended. Currency, yeah, currency is a huge number. Anyway, no one would have got that. That's fair enough. All right, let's close all that. Let's leave that. Good job to Seski Eski. All right, I don't know what this motorbike thing was about, but let's skip over it. All right, we already spoke about counting loops. Yeah, we spoke about counting loops. Oh, this is slightly different. This is just to say that it doesn't need to be counting by one every time, right? Like we can add not just one to our count or our sum. We can add, for example, the number of scoops. So we'll loop until we've had 100 scoops, for example, rather than looping 100 times. But the logic, the instructions, the expressions, nothing is changing in this example. If anyone also on the keyboard revealing week 4, I don't know why did I say week 4, but if anyone saw the Apple keynote yesterday when they had that like top-down camera feature, all I thought about was you guys. I thought you definitely would want that to see the keyboard, but iOS 16 is not here yet. Anyway. Okay, break. All right. Cool. So I should probably move the camera. Yeah, desk view. I thought chat would go insane for desk view. Okay. So really, that's loops. If you can understand that one loop structure, the while loop, we can use it in many different ways, but we can extend it. We can make it a little bit more, put some frills around the edges, but that's it. That's all we've got. And we can, play around with some more common and useful ways of using while loops, such as nested loops. So the idea that we can put a loop inside a loop, and that's something that might be, might not make sense to us very clearly. Let me put this down. Straight off the bat, but when we talk about it, it should make sense. And that's what we're going to talk about now. So the inside loop ends up running a lot of times. Yeah, it does. And we'll talk about... Okay, yes, I do remember. I said the assignment 0 mark. Yeah, I did say that. I do remember. Okay. Will says, what about conditional loops? I don't know exactly what you mean by that. All loops are conditional in that they only loop while something is true. That while something is true is the condition. But you might need to clarify what you mean exactly there. All right. So let's say we want to print out a grid of numbers, 1, 2, 3, 4, 5, and we want to print that out 5 times. How can we do this? In this case, this is a bit of a weird example because we could just we could print the string 1, 2, 3, 4, 5. And we could just loop once 5 times. Okay, sorry, just because Will said the what are we talking about with this condition loop? That's what I was talking about here by that we don't have to just add 1 to the counter. It doesn't just have to be a count. It can be any condition. So sum being less than 100, that's just some random condition. It's not a counter. That shouldn't say count loops. It's just a mistake. That is our condition loop. Yeah, it's just that is what I was talking about there. That loop, that you're right though, this had a typo on it. Sorry about that. Good catch though, actually. Okay. So if we think about this example, how could we solve this? Thank you for being so polite, Will. All right, let's go over here. What we'll do, we'll make a new file. Let's make VLab a bit bigger here. Bring that back over here, cancel this, gedit, we'll call it nested loops.c, ampersand, open that. Okay, cool. What do we always need? Int main void return 0. Oh, that's not nice. Okay. All right. Yeah, Anubis, we can put anything, any programmatic expression, anything can go in that condition. Anything, sum over 2, whatever, as long as it evaluates to be true or false, or 1 or 0. Okay. So let's go back to the slide for a second. So let's say, how can we print out this grid of numbers? Well, first of all, let's just print out 1 5 times. So I can just do printf. Now this is interesting. Like I could just print out 1. This is what I meant by I could print out 1, 2, 3, 4, 5, for example. But what if I wanted to do this, you know, to 10, to 20, to 50, to 100, 1,000? It doesn't really scale right. So there's a better way that we can do this. And some of you are already spamming chat with a really not nicely formatted solution, but yeah. So if I want to loop and print out 1, 2, 3, 4, 5. This is something we haven't done yet. So let's set up our while loop. So we need our int count. And I'm going to assign it 0 and not put a thing there. While count is less than 5, we're going to printf. Now I could print, if I wanted to print the value of count here, can I do that? Well, count is a variable. It's an integer. How do we print integers? The streaming delay is so... Yeah, we can print integers. We know how to do this, right? We can go %d and we can just print out count. So that's pretty cool. We can actually print out our looping variable. Let's compile it. DCC nested loops -o nested loops. And then we can just run nested loops. Oh, that's not right. Okay. Yep. So remember, I know a few of you are forgetting this. We don't need the ampersand if we're printing, only scanning. What did I forget here? I never incremented count so that it would actually reach 5. Otherwise, it's just going to loop forever and ever. Okay. Again, okay, what did I do wrong there? Did I save it? Did I not compile it? Oh, I bet that character stuffed it up. Yeah, I bet that I accidentally hit a key and it compiled into a different name. If I ls here, there's going to be, yeah, there it is. That's okay. All right, and I can actually put a new line here to get that looking a bit nicer. Okay, 0, 1, 2, 3, 4. Now, if we look at our lecture code, we actually wanted to do 1, 2, 3, 4, 5, but count started at 0. I could change it to loop from 1 to 6, but that's a bit confusing. So, but all I can just do is print count plus 1. That's completely fine. So now it'll start printing it at 1, but it starts at 0 in the actual value it's stored in the variable. And there we go. We have our 1, 2, 3, 4, and 5. Now this is just printing them on new lines, but you can see that in this example, we actually wanted to print 1, 2, 3, 4, 5, and then, 1, 2, 3, 4, 5 starting again. And we could also solve another way and print in this pyramid idea, but we're getting ahead of ourselves. Okay, so to do this, we can already sort of see that it's pretty hard for me to, I can't really solve this problem with just one loop. I actually need 2 loops. Now, I'm going to clue you into a bit of a convention. This count variable, when we're programming, it's a convention. So when I say convention, it's just an agreed thing that the counting variable is called I. It stands for index, and it's just, you don't have to, it's just a variable that we're calling I, but it's very common that you'll see this, that we call that variable I. So nothing else is going to change here, but I am going to change something. So I've got this simple loop here, and I'm going to, inside this loop, I'm going to start another loop. Now, I'm not going to put I is equal to 5. I want actually a separate loop counter for that loop in particular. And I'm going to call it J. Why do we call it J? Because it's one after I. It's just, again, the convention. And in this case, I'm going to say J is less than 0. We put our brackets here. And in here, we can actually cut this, put it here. Now, we increment I in the I loop. We need to increment J. Oh, that just needs to be I as well. In the inside loop. Okay, let's see what this does. It's not exactly clear. We're only printing I though, so let's also print J. And again, we'll add 1 to it. Now it's always printing in the inside loop. It's not exactly clear. Let's not put, let me think about it. Or why don't we do this? Why don't we print I in the I loop and print J in the J loop? How's that? Let's see what this does. And let's not put \n, we'll put a space instead. All right, let's see what this does. Oh. Okay, we're only getting, oh, what have I done here? This loop is never going to run because yeah, it should be 5. Don't know why I put 0 there. Okay, so we get 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5. That's not exactly what I was expecting, but that's probably okay. So let's think it through. I starts at 0. Is 0 less than 5? Yes. I think I already see what the issue is here. Is 0 less than 5? Yes, it is. So we start our second loop. Is J less than 5? And that is true. So J prints out J plus 1, so that's going to print out 1. So that very first one we see came from here. We add 1 to J, and then we loop again. We print 2, we print 3, we print 4, we print 5. That loop ends. Oh, I see. I think I see what happened. Yeah. Who's that? Kovsky 100% got the issue. We come down here, we print the 5 here, right? Then what happens? We come down here, we go back to the top. I never got reset, therefore I is still going to be 5. J is still going to be 5. And these loops are just not going to run again, and the program ends, and that's exactly what we see here. So it's not exactly what we wanted. Now, a few of you have jumped in and said, well, J doesn't reset to 0 in the loop. I will be, blah, blah, we haven't reset J. Now, this brings up a really good sort of point to discuss, and that is that where we declare our variables actually matters. We set this I and J variable to 0 up here in main. Therefore, and I'm going to get the whiteboard out again. Okay, let's go back to our whiteboard. Where did I put it? No? Did I quit it, really? Oh, there's an app. I might even just get the app one day. Okay, but that's okay. Let's go back here. Alrighty. This can go minimized. This can go over here. Sorry, it's a whole lot of window management to do this sometimes. Okay. It's just erase all this. Okay. If we have our program here, let's say we've got this box here that we have our program in. We have our I variable. We have our J variable. And we have our main function here. We can even draw that out. This I and this J get declared in main. Oh yes, it will be restricted. I'll fix that in a second, Nicole. This I and J get declared in main, and then the while loops also get declared in main. Therefore, the values in these variables sort of persist. Sorry, I'm off camera when I'm on the keyboard. They persist within the scopes. Oh, this is off camera. Okay. Yep. So let me just run through that again. I don't really have a... I don't know. Oh, I don't know. When we put our 0 in here and our 0 into J, they exist sort of in the main block. Therefore, they persist into these blocks. So the point here is that if we want to rerun the inner loop, we need to reset J back to 0. And there's actually a few ways we can do this. So we can just say that once this loop has ended, okay, we can just set J back to 0. So if we set J back to 0 at this point, this will end, and while will be set back. While we'll jump to the first while loop, the I loop, and J will be set back to 0, and that should execute again. So we can try this. Let's put this over here. Save this, clear this, jump back over to our nested loops. Whoops. Cool, all right, this is something different again. So we see something, so what's happened here? We've got 1, 2, 3, 4, 5 once. Then we've got 2 1s, that's interesting, but it's doing 1, 2, 3, 4, 5. Then it's a 2, okay, so that's a bit weird. 1, 2, 3, 4, but it's printed out that sequence, and then we've got this weird value that's getting printed out in between each one. So to make that even clearer again, what we can do is loop, let's see. After we finish this inner loop, we can print F just a new line to sort of reset the line. So that'll help us sort of understand even more what's going on. Okay, and we're getting slightly closer. So just by putting in, so what are you saying? I think that weird number is from the printfd I plus 1. Print this, delete this. Okay. Yeah, where did that come from actually? From the while loop, but yeah. But anyway, my point here was that we're getting closer. Like we have this 1, 2, 3, 4, 5. We have this extra print number coming out from, and it turns out it is coming out from line 15. But we're really close, but there's this extra value that's getting printed. This would be a perfect example where if we had more time, we would pull out the pen and paper and we would hand execute this program. And what we would find is that we would be printing these 1, 2, 3, 4, 5s from the inner J while loop. But every time that loop ended, we were also printing out the value I from the outer loop. But actually, we never wanted to print that out because we just wanted to print out this grid 1, 2, 3, 4, 5. But what I'm trying to show here is that this is a case where if it's too confusing and it's too much getting out a pen and paper and writing it out as it executes, you will see exactly what's going on. So let's save that. Let's do this. Let's compile it. Let's clear it. Let's run it. And we get out our beautiful grid 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. And we have that printed out 5 times. Okay. This is a pretty good spot to leave this program, I think. Let me just backspace this. Let me just save this. I did want to point one thing out. After this inner loop ends, we set this J variable back to 0. Justin, so it's Justin saying, why do we need to reinitialize J? So do you mean on line 14, Justin? I'm going to assume the answer is yes. Yep, the delay is quite annoying. The reason we need to do that is when we didn't set it back to 0, when we jumped back to this inner loop the second time, the value J was still 5. Therefore, it was never running. That was our first problem. So we need to reset it back to 0 so that this loop, the second time it runs, actually does run 5 times. But there's actually a second way we can fix this problem, and that is by declaring and initializing J inside the first loop. Okay, yeah, I will really quickly fix. I've got my, there we go. It should be fixed now. Sorry, the code should be available. If we create or declare the J variable inside the while loop, when the, actually no, will this actually solve it? I don't think it will. Well, am I just talking a bit of crap? Because it's still going to exist inside that. No. Yeah, I was right. When the while loop ends, J gets set back to 0 here, and it's like a separate J variable. So you may be sort of, I'm not really expressing myself very well here. You may be drawn to do this, but there's actually an optimization reason why we might not want to do this. Can anyone pick it up? Why is this maybe not as clean as what I had earlier? Yeah, Kofsky's got it straight on the money. So does Daniel, so does Adam. Because it's an actual declaration, I'm asking for another piece of memory to store an integer. It's actually creating 5 new J variables. So it is more efficient to do it this way and set J back to 0. If you're watching this video and this isn't really making much sense, that's okay. Go back and maybe watch the video again, or when you can ask your tutor or post on the forum and get some help that way. But yeah, really good to those of you who spotted that. So this is pretty good. I think I'm pretty happy with this. I'll save this. This is called nested loops. And so I'll keep that there. Let's go gedit nested loops 2.c ampersand. Just before I do that, let's see. Cyril says, but doesn't the variable's memory get declared before the main function runs? Okay, that's a really good question. And the answer is no. The answer is the memory gets declared when the operation that requests that memory is declared. In this case, that was running 5 times, so it would be creating 5 new integer variables called I. Same identifier, but they're not existing at the same time. So it's only ever using the same amount of memory. But it could be in different places. It could have been moved around because it was requested 5 different times. Whereas what we're doing here is reusing that memory. So AR11 says an int is 8 bytes. By putting it at the top, it requires 40 instead of 8. It's using more memory, but not all at once. Does that make sense? It's asking the operating system for 8. I guess the key is that it asks the operating system for the integer. When the loop ends, it loses it. So it tells the operating system, oh, I don't need it anymore, and then it asks for some more back. So it is still not as efficient, but it's not using 8 times 5, 8 bits times 5 all at once. Okay. Yeah, Kofsky's got it. It's more strenuous in the system because it's repeatedly asking for the same amount of memory. Okay, Amazing Music says, how does it know that the old variable isn't valid anymore? That's also an excellent question. When we have a block of code, I'll delete this from the file, but if I've got while something and here int x is equal to 5. When I start this block, or actually we can just make this an if statement to make it even simpler. When I start this block, I request the 8 bits for the integer. The block ends, and that's it. The integer's now gone. This integer only exists within this block. Once the block ends, the program tells the operating system, I don't need this memory anymore because I can't go back into that block. This is called scoping, right? So this variable is only existing within this scope. And it's something we're going to talk about more in the future. It's more complicated than this because scope is inherited. So the I and j exist in here and they exist after, but x does not exist after, for example. But we will talk about it more in the future. Don't stress too much about it. I just wanted to point it out. All right, we can open our final file today. Now let's go back to get a refresh. I'll minimize that. I'll learn my lesson. Oh, there it was. Oops, wrong thing. So that's the first problem we wanted to solve. And we have a slight variation of it for the last 10 or so minutes. What if we wanted to print out a half pyramid? So the first time we run the loop, we want to print out a 1. The second time we want to print out 1, 2. The third time 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5. So once again, we need to break down the problem, think about it, and solve it. So instead of me just standing here and writing some programming, we've got 20 minutes. Why don't we all get our VLab running, if you can, if you're at a computer. And why don't we start to solve it together and write the program together. So I'll give you all a few minutes to get your editors open. And start letting me know when you're all ready. Someone's solved it very quickly. Oh, I gotta stop forgetting to chmod though. There we go. So this file should now be available. A few people are ready. I'll give you all a few more minutes. Okay, cool. All right, so let's solve this program together. Remember, it's good to list what we're making. This program should create a pyramid using nested while loops. I can put Jake Renzella. You can all put your own name. Don't copy that part if you are copying. All right. So what are we trying to do here? Yeah, the file should be. Okay. Yes. Yeah. Anyway, we're not talking about compiler optimizations, Cyril, but yeah, you probably are right there. Okay. Alrighty. Okay. So include stdio.h, right? We always sort of have this include statement so we can do printing and scanfing. We all should be happy with that. Int main void. Yep, sure. I'll try and slow down a little bit for those following live. And this is just our basic boilerplate. Now, let's try and be a bit more pragmatic about this. We know we want a number of, like we want some height or some, how, tall, or I guess what's the word here, tall or wide our pyramid is. We can just call it maybe height. So we can define that as a variable. So our int height, we can start it off as 5 because we want to sort of solve our brief, right? Because remember, we wanted to make a pyramid that was like then it was like 1, 2. Whoops, got ahead of myself. Right, this is what we wanted to print out. So I'm going to say that this pyramid has like some height of 5, right? Good catch. Thank you very much, AR. We always return 0 at the end. Yeah, very good. Okay, so we have this height of 5 variable that's going to just help us determine when we should, start it in the loop rather than using the number 5 hard-coded into the value. All right. So we can always then start with our int I is equal to 0. That's not an equal sign. Int j is equal to 0. Is it meant to be return 0? No, we can return 0 just like that. That's okay. Cool. I'm going to assume that Patrick's happy answering Nicole's question. It's directed at him. That's completely fine as well. All right. So let's start off. We need to do some looping here. We need to have a while loop. So while, and we'll start with the outer loop first. The outer loop, the first counting loop, is always using I. So that's pretty simple. While I, now we want to loop, we want to have a height of 5. So we can just say while it's less than. Now, rather than just saying 5, what should we be using here? The variable height. Exactly right. Exactly right. So while I is less than, it's still the value 5, but it's using that variable name, so it's more sort of dynamic. Do we need a space between the numbers? I think it looks good with a space between the numbers, yeah. Less than or equal to height will actually be 6. That would actually be 6 loops, right? Because 5 is equal to 5, so it would do one more. So it's just less than height is okay. Alternatively, we could do something like less than or equal to height minus 1, but let's not get crazy because we're starting at 0. Yeah, exactly right. Yeah, that's fine. You will. These are called off by 1 errors. You will make many of these throughout your programming career, where you'll do something 1 too many times or 1 too few times. Okay. Let's see here. So the first time we run this, Well, we need our nested loop because we need to loop the inner loop. So we tab over while. Now, what are we going to do here? If we do j is less than height, then it's just going to print out all 5, right? So if we think about this first time we're printing, while I is less than height, so while 0 is less than 5, we just want to print out, the first thing we want to print is just the number 1. That's it. We only want to loop, in this case, 1 time. How can we loop 1 time? What's the way we can solve this? Let me read the chat really quickly. Jake, since our first number is 1, each row should start from 1 instead of 0. To solve that, we'll just print by +1. Okay, we'll just print by +1 so that we'll start at 1. Nickel says, we do j is less than I as we want the diagonals. Kovsky says j is less than I. Okay, we've got to break this down. We probably do need to hand execute this one. So people in the chat are saying j is less than or equal to I. Now, let's really think about this. Well, what is the value of I? It's counting the rows, right? Yeah, the rows. That's the first row, that's the second row, that's the third row, that's the fourth row. So if I is counting the rows, then I is the number of row we're up to. So if we're at the first row and I want to print 1 time, then that is just going to be 1. I is going to be 1, or 0 in this case. And j is going to be assigned at 0 because we're at the 0th column. So is 0 less than or equal to 0? This is going to be true. So we can print what? What do we print out here? It's going to be, I know it's going to be an integer, so I'll get that ready. It's going to be a comma. We'll put a space after it. We will put a space after it. J plus 1. Why the +1? Because we want to print 1. We don't want to print 0. But that's nothing too interesting. And I've got a space after it as well. Whew, okay. We need to make sure that we progress our loop. So j is equal to j plus 1. We always have that. And we always need to have our I is equal to I plus 1 so that we actually progress. And just like last time, after the inner loop print, so after the columns get printed, we want to print a new line. So that's just going to be here. Printf, whoops, \n, semicolon, save. Yep, cool. All right. Someone asked, why did I use less than or equal to for the j loop? Yeah, you're right. That's not really very nice, is it? It's because I wanted loop when j and I are both 0, so I need less than or equal to 0. However, maybe to make that nicer, this would make more sense. That way they're both less than or equal to. So height is 5, 5 minus 1 is 4. So this will still print 5 times. And this will loop when the numbers of the column and the rows are equal. And then, yeah, a few of you have mentioned that I need to reset the column. J is the column, and that's going to reset here. Yeah. No, it's not. Yeah, that's fine, isn't it? I think that's okay. Well, let's find out. Someone will check why your Tiger VNC keeps crashing. I'm not too sure why. Okay, DCC nested loops _2 -o nested loops 2. Oh, look at that. No errors, but is it going to work? It might not. _2. Oh, look at that. On the first try, we get this beautiful pyramid getting printed out. 1, 1 and 2, 1 and 2 and 3, 1, 2, 3, 4, 1, 2, 3, 4, 5. Another way of thinking about this that might make it more easier to understand, because it is a condition, it is a convention to use I and J. But if we just go gedit pyramid.c ampersand, paste this in, what you can think about is that I is really our row, and it's really annoying that I'm going to have to... Is there a search and replace in gedit? Does anyone know? And J is our col. Control H. Yeah, but that's not gonna do. It should be okay, but that's a bit, for one letter, that's a bit dangerous because it might get other things. It's not like a refactor. Anyway, oh, no, that should be, what have I done wrong here? That should be col. That should be col there. Okay. Maybe written like this should also be col. Maybe written like this, it might be easier for you to understand. I'm not too sure. You know, while the number of row, I should actually put in back this as well. Might also help. Okay, you can do match entire word. It'll only take the I. Yeah, I know there's, yeah, I'm sure there's a way to do it. So these are equivalent. Can we think of anything to improve this program? Well, one thing just to be fun is that because we use this height variable here, we set it to 5. What does that mean? Well, we can utilize the performance of our computers to do things that would be much more complex for us to do. I'll do it back in this file. Just because I've already got it loaded up, so to speak. Oh, that should be at 50, not a 5 minus. Thank you, compiler. See, computers are unintelligent. They can just tell us the things that they see, not what we wanted to do. Nested loops _2. Okay, well, if it's wider than the width of the terminal, that's not really helpful, but we can maybe do up to 28 then. That looks like, that looks like it might fit. There we go. That's pretty cool, isn't it? And just by changing a few numbers, we're controlling the amount of cycles and repetitions our computer is executing. How cool. I mean, it's simple, but I think it's pretty cool. Yeah. Okay, and beautiful timing as well. It's 4:55, exactly at the end of the lecture. So Cyril saying you should declare J without assigning it and set J is equal to 0 at the beginning of the loop, so you can only assign 0 to its height times. You can declare J without assigning it. Oh, are you saying I'm assigning it height plus 1 times, Cyril? Because I assigned it on line 19? Yes, I see what you're saying. Yeah. Okay, yeah. Cool. It's always good to initialize our variables, so yeah. Okay, I wasn't, yeah, anyway. So someone's asking, how could you mirror it to make a full pyramid? That gets, that could be your challenge exercise. I mean, you could figure out how to do it. So someone is saying, I copied and pasted the code, but it only prints, well, there's your first problem maybe, but it only prints up to 1, 2, 3, 4. However, when I change int height to 6, it prints like yours. Yeah, I'm seeing the curve as well. I must admit, and the reason for that is actually quite simple, I think, and that's because they're not mono-width characters. So 11 is narrower than 10. So this line is narrower than this line. So I think it looks like it's curving. And yeah, and there's 2-digit numbers. Yeah, that's all it'll be. So the less 1-digit characters, the narrower the line, I think. Okay, and now there's a... now the bots are... Yeah, yeah. Well, we got through the... So I will say on that, actually, for next week, I think I've figured out a setting that'll stop this happening. But it means that the URLs for the live stream will be generated fresh each time. So make sure you watch the announcement for the URL for the stream. But I think I've figured out a way to get that stopping. Yeah. Attack of the Clones, yeah, exactly. But anyway, I hope you found the repetition or the while loop lecture really interesting. I'm sure a lot of you will watch these videos and come away thinking that was a lot of content in a very little amount of time. That's really complicated. That's okay. Remember, you get the hands-on time next week in the tutorials. So that's where you'll get to practice, right? Don't forget that. So the lectures, we've structured it in a way that the lectures are 1 week before the content, so that everyone has a chance to get up to the material before you get your hands on. Okay, it's 5 o'clock. I'm slurring my words. I can already tell. I'm running out of steam. Please fill the feedback form out if you would like to. We've had 43 people provide feedback on the lectures. Most of the feedback is on timing. Timing is a tricky one. About half of you say to go a bit faster. About half of you say to go a bit slower. It's a tricky thing to, it's not an easy thing to solve, but I'm always trying. There's some feedback on, for example, lecturing the number slides. I've got Noah going through all the lectures PDFs and putting the numbers on the PDF on the slides. He's working on that. Let's see, what was some of the other feedback? In fact, I can bring it up while we... Yeah, if it's half and half, keep it the same. That's exactly right. But potato, if it's half and half and I keep it the same, then no one's happy. Maybe I should just pick one and make half the cohort happy. Yeah. Yeah, lecturing is that what I said? Did I say that? Oh god. It's only a Wednesday as well. I shouldn't be running out of steam. But lecturing is pretty tiring. So let's see, what are some of the other feedback? This one says good job. That's really nice. Thank you. More instructions on how the terminal works. It's unfamiliar. On that, actually, I should plug. Let's have a look here. Yep. Hold on. Or Tammy or Patrick, could someone link the Lab 0 stuff from CSC SOC? There is a cheat sheet somewhere on the course website. Make myself happy, that's really sweet, but I'm okay. Thank you. Yeah, here it is. Cheat sheet. All right, Tammy's getting that. Oh, that's a big cheat sheet, but... So that's just on the course website at the bottom. I know, maybe you got to the assignment and then freaked out and never read it. But so CSC SOC, which I'm sure many of you have heard of, are the student CSC society. Really big, really organized, really great. They have put out this resource called Lab 0, which is all about getting familiar with, I don't really know how this works. Maybe you have to log in. I don't know what this is. Scoreboard? I've never actually looked at it. I probably should have. You probably have to log in. Okay, and I think I'm right. There's some like terminal stuff in here. Is that right? It looks actually quite cool. I should this could be the next lecture, mid-lecture game that we do. But anyway, there's a bunch of really useful UNSW specific information. Everything from VLab through to the terminal, all of that gets covered in Lab 0, run by CCSOC. So I recommend you check it out. They've got some awesome resources there. Dominate the leaderboards. Yeah, no one use Jake's dad as the username, please. So there's that. What else? Let's see. And by the way, that's the end of the lecture. So if you want to head off, you can head off. I will see you next week. Have fun in your tutorials. Good luck with assignment 0. Remember to use the forum. Someone asked about help sessions. They start next week. We'll put out an announcement sometime this week with all the information on the help sessions. Those are really exciting. Let's see. Was there any other feedback I wanted to talk about? No, actually, a lot of you are being really sweet. A lot of you are asking to see my keyboard as well. Again, we'll talk about that if you beat last term's course. Cool. All right. I think we'll leave it there. Thank you all so much. I've had a great 2 hours. I hope you've had a great 2 hours. Enjoy the rest of your week. Thank you, Tammy and Patrick, for moderating. Thank you for the bots for being cooperative. See you next time. Thank you all.